Alright, guys, I know you're super pumped up to use some of the bisector properties we talked about in the PowerPoint video. So this first one is dealing with segment bisectors, which remember, bisectors slice things in half. They're these cruel little items that just cut everything in half. Okay, they're kind of mean. So anyways, in this scenario, it says that segment AB bisects PQ. So PQ, it will slice it in the middle, which means it hits the midpoint and makes two congruent segments. Okay, we can always say that about a bisector. So if PQ, so if the whole piece is 3x plus 4, so I'm going to label that real quickly. So P to the Q is 3x plus 4, and PF is 2x minus 3, so this piece is 2x minus 3. Find the value of x, PF, FQ, and PQ. So we have a lot of things. All right, so based on one of the bisector theorems we talked about, the way we get from a smaller segment to the larger segment, since we know that this is half of the larger segment, there's two ways we can do this. We can either say that this segment equals 1/2 of this segment, or if you don't want to deal with fractions, what we could say, the way we get from here to here, if we double segment PF, we will get segment PQ. Alright, or another way, since we know that these two segments are congruent, you could also label this one 2x minus 3. So there's several ways that you guys can solve this. Now the way that I'm going to choose to solve it, which you don't have to do it this way, but this is just the way I'm going to do it. Alright, so I know that PQ, my big segment, if I double one of my smaller pieces, I should get the length of the whole thing since this piece is half the size of this piece. So if I double the length of PF, I should get the length of PQ. Okay, so now I'm going to fill in the pieces where they belong. So my PQ is going to transform into what it equals, which is 3x plus 4. And that will equal 2 times my PF, which that is going to transform into a 2x minus 3. Alright guys, let's start solving this thing for x. So, the way I solve for x, first of all, I need to deal with this 2 out in front of my parenthesis. Which the way that we deal with numbers out in front of a parenthesis, you guys are so smart, it is by distributing. So I'm going to distribute my 2 to each of these numbers. Okay, so what I'm left with is 3x plus 4 equals 2 times 2x is 4x, and 2 times negative 3 is negative 6. Alright, before I can solve for x, I need to start combining my x's together first. I need to bring them together because they're besties. I'm going to choose to bring 3x to the other side because it'll keep my x's positive. So the way I bring a positive 3x to the other side is by subtracting that thing on both sides. Which 3x minus 3x cancels and turns to 0. 4x minus 3x is 1x, which is the same thing as x. Okay, so now I have 4 equals x minus 6. Alright, now that my x's have been brought together, now I need to move everything to the other side. So the way I bring a negative 6 to the other side is by adding that thing on both sides. Which negative 6 plus 6 cancels and turns to 0. 4 plus 6 is 10. So we're left with x equals 10. Holy hot dog. Yay, so we know one of the values. Okay, but I'm not done. I need to find PF, FQ, and PQ. Okay, which I know that PF and FQ are congruent, which means that their segment lengths are equal. So if I find one of these segments, I can easily find the other. So I'm going to do that over here, you guys. I'm going to break this off. So I know that PF, segment PF, is congruent to segment FQ. And if these objects are congruent, it means that their lengths are equal. So the length of PF equals the length of FQ. So if I find PF, bam, I've instantly found FQ. So why don't we solve this thing for PF? So I know PF equals 2 times x minus 3, which I know what x is, so guess what? I can just substitute in this 10 for this x right here, and then I can solve. Okay, so PF is going to equal 2 times my x, which my x is going to change into a 10, and then minus a 3. All right, let's solve this thing for PF. So 2 times 10 is 20. So PF equals 20 minus 3, which means PF equals 17. Oh man. Which that also means that FQ has to also equal it since they're congruent. So FQ